Friends, now we are going to discuss about effect of exercise on respiration. During exercise, O2 demand of body get increased, and total amount of O2 entering the blood generally increases from 250 ml per minute to your 4000 ml per minute. Okay, and with increase in O2 demand, increase in CO2 excretion will also increase due to the increased metabolism within the cell. So it will increase from 200 ml per minute to as much as 8000 ml per minute. And increase in O2 uptake is directly proportional to your workload up to a maximum level. Okay, increase in O2 will directly proportional to your workload. Okay, but it is up to a maximum level. After that, the carrier of O2 is saturated, due to which no more oxygen will be transported. Now move to the next slide. This additional O2 is supplied by basically two methods. First, increasing cardiac output, and the second one is increased extraction of O2 by tissue. Because the data has suggested this, that is increased extraction of O2 by tissues, because we have seen decrease in venous O2 tension to 25 mg from 40 mg. Okay, so basically two methods to supply additional O2, that is the increased cardiac output and increased extraction of O2 by tissues. Now, as soon as your exercise starts, there will be increase in ventilation, followed by gradual increase up to a maximum level. Okay, and this immediate increase, as I said, that as soon as your exercise starts, ventilation will increase, and this immediate increase in ventilation is due to four reasons. The first one is stimulus from proprioceptors. The second one is increase in temperature. The third one is your increase in potassium concentration, and the fourth one is your lactic acid formation. So these are the basic four stimuli for increase in ventilation as soon as we started exercising. Now, when exercise becomes more vigorous, more CO2 released, okay, due to buffering of more lactic acid, because lactic acid is forming due to anaerobic glycolysis. So lactic acid buffered to release more CO2. Move to the next slide. And it will lead to increase in ventilation more, because more CO2 is produced due to the buffering of lactic acid and metabolism of the cells. With increased lactic acid, increased CO2, and firstly, the increased amount of CO2 is directly proportional to your ventilation rate. Okay, so basically keeping the arterial PCO2 level relatively constant. But as the exercise is going more vigorous, more amount of lactic acid is formed, the amount of CO2 formation and your ventilation rate will get mismatched, and ventilation rate increases more than the amount of CO2 formation. But before that, in CO2 formation is proportional to your ventilation rate, and because of this your arterial PCO2 remain constant, and this is known as isocapnic buffering. But with further increase in lactic acid formation, increase in ventilation, outstrip your CO2 protection, as I have said, and this will lead to decrease arterial PCO2 level, and it provides respiratory compensation for metabolic acidosis due to increased lactic acid. Okay, so this is the reason, this is the benefit due to lowering of PCO2. Now on to the next slide. Now, respiratory rate after exercise does not reach basal level until O2 depth is repeated, as I have discussed O2 depth in your separate video, and this take usually 90 minutes. Okay, and stimulation to ventilation after exercise is not arterial PCO2, because it is normal. Arterial PCO2 is normal, as I have discussed here. Arterial PCO2 level falls or becomes normal, and arterial PO2 is also normal or greater, but this increased ventilation after exercise is due to your stimulation by H+, and increased H+ is due to lactic acidemia. Okay, so this is all about the effects of exercise.